Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No, we've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you can ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam, Praxis peeps, big shout out to you guys out there too. And especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hi, friends. How are you guys? Welcome to Wednesday Night Math Night. Like Dr. A said, I am Amy Sink, and I am one of the math specialists here at the Learning Liaisons, and I just love what we get to do, which is help you feel more confident in your math skills and in your ability to do math, which is going to, in turn, help you be more successful on your math exam. Of course, I like helping with all of the math skills as well and helping you just gain some knowledge there. But my favorite part is allowing you and helping motivate you and helping make you feel like you've got this, because you do. That mental piece of it is a huge piece of these certification exams. And so when we don't believe we can do something, we begin to believe it to be true, whether it is or is not. And so that affects our ability to retract the knowledge that we already have in our brains, which again, you might believe that you don't have that knowledge, but I know that you do. So with that said, I am Amy Sink. I am from the Orlando, Florida area. No, we do not go to Disney every weekend. Do I wish we did? No. In the wintertime, I love Disney, but in the summertime, it is just way too hot, y'all. I was out in that area earlier this week for a huge teacher conference. One of my good friends works out there for the conference, and so I had the opportunity to go out there and just serve teachers and help with that conference. And so that's actually where this shirt is from. Hey, you. So that was super fun. But what are y'all up to? I wish we could all be in my living room, catching up on life and doing math together. In the comment box, let's make it feel a little less computery. So in the comment box, let me know where you're from. What test are you prepping for? So where are you from? What test are you prepping for? And are you a rides person or more of like a show person when you go to a theme park? Are you a rides person or a show person? I would consider myself a healthy mix of both. I love rides. I love going on rides, but I don't like roller coasters. I don't like big roller coasters. They make my belly feel weird, but I live for like kiddie roller coasters, like the Snow White roller coaster at Magic Kingdom is my jam. Or like any other, like I like the raft rides. I like the just get in a boat and ride rides. Like I love all of it. I just don't do big roller coasters. So where are you from? What test are you prepping for? And are you a rides person at a theme park or like more of a shows person? I also come from a theater performing arts background, and so I do love watching the shows, but that's not what I want to do all day. I want to get on some rides too. As we are working today, let me know what you want to see me go over in upcoming sessions. I always run like a next week section. And in fact, a good chunk of tonight is specific requests from people who have said, hey, I really want you to go over this concept, or hey, I'm really struggling with this. Can you go over this? Or they've sent me exact questions that they want me to go over. So as we are working today, let me know what you want to see me go over in the coming weeks, and I will absolutely add that to my list of topics. And we will get started. Hi, Lydia. It's good to see you. You're from Texas. You're a show person, but you like the rides that aren't roller coasters too. You are my twin. You're my spirit animal. We are the same person. You like the Small World and Peter Pan and Carousel. Do you like teacups? That's a good question. Do you like those spinny rides? Can we do a graph problem with parabolas? Absolutely. Love that. I will do that next week for sure. I pre-create the problems, but yes, graph problem with parabolas. That's a great one. I love that request. Anything else you think of, Lydia, let me know and I'll absolutely add it to our list. All right, let's go ahead and start with problem number 1. Which of the following is a factor of f of x equals x squared minus 1x minus 6? Which of the following is a factor of f of x equals x squared minus 1x minus 6? So 2 weeks ago when we were here, somebody specifically requested factoring help. So here's what I want to do. I want us to chat about key vocabulary when we're talking about parabolas, quadratics, and factoring and all of that, because we have vocabulary that all kind of means the same thing. And it can be very confusing on how to differentiate what a problem is asking when we use the same word to describe similar things. So a quadratic equation creates a parabola. A quadratic equation is an x squared equation. It creates a parabola. When we are finding the zeros, we are finding the x-intercepts, which can also be called the factors. It's like the step before or the step after factors. So once we factor it, then you can find the zeros and the x-intercepts. So I'm actually going to do this. Once you find the factors, then you can find the zeros and the x-intercepts. Now, from that understanding, which of the following is a factor? Remember, a factor, and this is important for everyone. So even if you don't have quadratics on your exam, you need to know the definition of a factor. A factor, by definition, a factor is a number or quantity that when it's multiplied with another gives an expression. Or it's like the thing, like you have two factors that multiply together to give me a product, right? So a factor is a piece of a like multiple. So like a factor and a factor makes a multiple, right? Or a factor and a factor makes a product. And so when I think of factor, I think of something multiplied by something else is going to result in whatever I have. So which of the following is a factor? I need to know what multiplied by something else is going to give me x squared minus 1x minus 6. So we are going to do what's called factor this. I'm going to factor this quadratic equation. So x squared minus 1x minus 6. To factor a quadratic equation, so there's all sorts of methods, y'all. I'm just going to say this. There's the turtle method. There's the X method. There's the multiplying and adding method. There's the MAD method. There's all these different methods and tricks to factoring. And through my tutoring years, I have figured out that kids are given multiple different like methods for factoring. I cannot wrap my brain around them. And so here's what I do. I end up just thinking about, all right, I'm just going to think about it like this. And what I'm about to show you is the way that I do it every single time. I will also show you the area model so that you understand that. Ayana, which one is the fastest? Whichever one you're best at. Honestly, the turtle method, the X method, the MAD method, the multiplication method, whatever, they're all kind of about the same amount. It's just whichever one you're more proficient in. And so when I'm factoring, I'm always going to set up my parentheses. And when I set up my parentheses, the item that goes here are things that multiply to give me this. And the items that go here are the items that multiply to give me the last one, but add to give me this one. So if I just have x squared, I know that x times x is x squared. That's the easiest thing. So if you're factoring a quadratic that is this kind of quadratic where we only have like an x in the front, those are the easiest kind to factor because I don't have to take into consideration anything in the front, a coefficient in the front. I just know that an x and an x are going to go there. Now, I need to figure out what adds to give me -1, but multiplies to give me -6. So here's what I do every single time. It's the fastest way for me. I think about what multiplies to give me -6. 1 and 6, 2 times 3, and that's it. Those are the only sets of factors. Once I literally list them on my paper, which of these pairs is going to add or subtract to give me a -1? Which one has the potential to add or subtract to give me a -1? It's not 1 and 6. 6 plus 1 is 7. 6 minus 1 is 5. They're not close enough. So this is going to be my winner. Does it matter where I put it? No, because multiplication is commutative. I am throwing so much language at you right now. Multiplication is commutative, which means I can do it in any order. So 3 times 2 is the same thing as 2 times 3. So I'm just going to plop a 3 here and plop a 2 here. Where the symbols go does matter. Where the symbols go does matter. So am I going to have a -3, a -2, negatives on both, positives on both? I need a -6. I need to multiply to get -6. So in order to multiply to give me a negative, a positive times a positive equals a positive. A negative times a negative equals a negative. A positive times a negative equals a negative. Oh, a negative times a negative is a positive. I don't know why I did that. A positive times a negative is the only way I'm going to get a negative. So one of them has to be positive and one of them has to be negative. But remember, I need to add to get -1. How am I going to get -1 with a 3 and a 2? A -3 and a +2. So which one of these matches which one of these? That is a factor, because this multiplied by something else gives me a bigger number. That's what a factor is. Now, if it said which of the following is an x-intercept, or which of the following is a 0, then I would have to take it one step further. And that's the next problem we're going to solve. Then I would have to take it one step further. But I don't have to do that because they asked me for a factor, which are the things that multiply to give me a bigger thing. Did the factoring process make sense? Let's do another factoring example. Ayana, another way you could do it is the area model. It's the only other model that in my head makes sense. So if this was a real rectangle, how do I find the area of a real rectangle? I do length times width, right? And so if I'm doing length times width to get this, I know that this box right here is going to be this guy. And actually, let me rewrite it so that you can see. X squared minus 1x minus 6. So that box is for this. This box down here is for this. And these two boxes are for this. And let me show you how. So what times what gives me the green? X times X is green. And then the blue has to be something plus something else, or something times something equals that, but then something plus something equals the pink. So the pink is going to be multiples of the 6. So I could do a 3 and a 2, and that gives me 6 because 3 times 2 is 6. So if you look up the area model for how to solve quadratics, that might visually make more sense than what I did. All it is taking what I did and putting it into a visual model. So it's one way you could solve it. Let's go ahead and do another factoring example, but this time it's a little bit more complex. Which of the following is a 0 of f of x equals 3x squared minus 10x minus 8? So when we're looking at zeros, we're looking at the next step. So for the problem before, we were looking at factors. We were looking at what times what is going to give me my bigger thing, my bigger item. Now I'm going to take those factors and solve them to get my zeros. Remember, my 0 is also my x-intercept, which is also where my graph crosses the x-axis. And x-intercept is my 0, which is where my graph crosses my x-axis. X-intercept 0, all the same thing. This is not an accurate picture of this graph. It's just one that I whipped up. So let's go ahead and explore this. 3x squared minus 10x minus 8. I always set up my parentheses first. That's my first step. And this all has to equal 0 because we're looking for our zeros, right? We're looking for our zeros. So this time, we don't just have an x right here. We have a 3x. So now I actually have to think about what times what gives me 3x. Well, it's easy peasy again, because I can do x and x. That's going to give me the x squared part. But what times what is 3? Only 3 and 1. That's it. 3x and 1x. That's it. 3x times 1x is 3x squared. That's the only possibility. Now, could you do this, 1x and 3x? Sure. I always do the larger number first. I don't know why. It's just habit. But that's just what I do. Now, here's where it gets tricky. In the previous example, these numbers were numbers that multiplied to give me this, but added to give me this. They are still numbers that multiply to give me this, but here's my but. This coefficient is going to play into adding to give me 10. This is where these problems get tricky, and it's just, you have to play with it. So I'm still going to list the factors of 8. 1 and 8, 2 and 4. That's it. Now, pro tip, 9 times out of 10, you're not going to use this one. Normally, you're going to use anything but a 1 and an 8, right? Does that mean it's always going to happen? No. You could use the 1 and the 8, but a lot of times you're not going to use the factor that's 1 in itself unless you're looking at this first coefficient. You're just not. I don't know why. It's just not common. But if I were to plug the 1 and the 8 in, if I put the 1 here and the 8 here, think about how we multiply this back out to get to our ultimate product. When I multiply this out, and this is like a totally different lesson. This is like quadratics, like in 2.7 seconds. When I have x plus 2 and x minus 6, and this is a total side note, so I'm actually going to zoom in so that you don't think it's part of the problem. When I multiply this out, I use FOIL. First, outer, inner, last. I can also think of it as the distributive property. Elementary people, you need to know what the distributive property is. So even though you don't need to necessarily know what this is, you need to know what the distributive property is, which is I can take something and distribute it all the way through. So this x gets distributed all the way through. First, outer, inner, last. First, outer, inner, last. But if I think of it just as the distributive property, I'm distributing the x all the way through, then I'm distributing the 2 all the way through. X times x is x squared. X times negative 6 is negative 6x. 2 times x is 2x. 2 times negative 6 is negative 12. You see how I multiplied this times both of these. And then I multiplied this times both of these. So when I'm looking at that, this 3 is going to play a huge part in what adds together to give me that 10. That 3 adds together to give me that 10. So it's important that we pay attention to that. So now let's go ahead and look at that as a part of this problem, which is you're going to see why it like these problems with those extra those extra coefficients are just lengthier. That's all. They're just lengthier. So if I throw the 8 and the 1 in there, I'm going to end up with 3x squared, which is exactly what I want. And then I'm going to have 3x and 8x. That gives me 11x or 5x. That's not helpful. So now I'm going to flip the 8 and the 1. Now I have 3x squared. Don't need to worry about that one. 24x and 1x. Is that on any planet going to give me a negative 10? No. So now I'm going to play with the 4 and the 2. 3x squared, 12x, and 2x. Is 12 and 2 going to give me negative 10? Could it? It could. 12 and 2 could give me negative 10. How? How is a 12 and a 2 going to give me a negative 10? Which one has to be negative and which one has to be positive? The 12 would have to be negative. The 2 would have to be positive because negative 12 plus 2 equals negative 10. So how am I going to make that 12 a negative? By making the 4 negative, because 3 times negative 4 is negative 12 plus 2. Now, we're still not done because these are the factors of 3x squared minus 10x minus 8. These are not the zeros. To find the zeros, I have to do 3x plus 2 equals 0, and I have to do x minus 4 equals 0. Now I just solved for x. Now, this is elementary through high school. Everybody needs to know how to solve a basic equation. Minus 2, 3x equals negative 2. Divided by 3 on both sides, x equals negative 2/3. Bingo! Add 4 to both sides, x equals 4. That's not even an answer choice, so x equals negative 2/3 is the answer. Questions? That was a lot of information. Now, I'm going to take this one step further because someone today asked, can we do a graphing problem with a parabola? We can graph this one right here. Let's do it. So I am going to now say graph that problem. Let's do it. Now, I will do another graphing problem next week, but I just want to show you how to graph this since we are here. I am going to find my zeros first. So if it said graph 3x squared minus 10x minus 8, my first thing that I would do is find the zeros. 1, find zeros. Now, if it doesn't factor, which is entirely possible, then number 1 wouldn't be possible. But I'm going to plot 4, 1, 2, 3, 4, and I'm going to plot negative 2/3, which is going to be about here. Then I'm going to find my vertex. With any parabola, you can find your vertex by doing this. X equals negative b over 2a, where a is attached to your x squared, b is attached to your x, and c is by itself. So I can do x equals negative, b in this case is negative 10 over 2a is 3. So negative times a negative is a positive 10 over 6, which is 5 over 3 divided, 5 over 3. So the x part of my vertex is 5 over 3. The y part can be found by plugging that 5/3 back into the equation. So 3 times 5/3 squared minus 10 times 5/3 minus 8. 3 times 25/9 minus 50 over 3 minus 8. If you don't know how I just got 25/9 and 50/3, then ask, because that means that you're struggling with fractions, and that's okay. These cancel out, so 25/3 minus 50/3 minus 8, negative 25/3 minus 8, which is the same thing as 24/3. So that equals negative 49/3. So over 5/3, down -49/3, and then I can graph my parabola. So the easiest way to graph your parabola is to find your zeros, number 1, find your vertex, number 2. And then you have 3 points that you can connect. I will do a more complex graphing parabola problem next week, but because you asked and we had a parabola right here that we could graph, I wanted to graph it. All right, let's go on to problem number 3. Well, technically it's problem number 3, but I had problem A and problem B because these were from last week, or like this was a request from last week. So now we can actually go into problem number 1. So, which of the following is equal to the area of the rectangle? Which of the following is equal to the area of the rectangle? All right. So you're probably looking at this and going, what? This was a specific request from Facebook. Someone posted this on our Learning Liaisons Facebook page, and I said, I will solve it on a Wednesday. So here we go. With this rectangle, we know area of a rectangle. Now, again, elementary people, don't go away from me because you need to know how to find the area of a rectangle. Then you can check out from this problem. Area of a rectangle equals length times width. Got it? Okay. So I know I need to do length times width. What else do I know about this problem? What else do I know about this problem? Well, I know I'm probably going to have to use sine, cosine, and or tangent because when I look at my answer choices, there's sine, there's cosine, there's sine, and there's cosine. So if you are completely stuck on this, start doing something with sine and cosine because it's part of your answer choices. So I know that the relationship with sine and cosine and tangent in a right triangle is SOHCAHTOA. So I know that sine of theta equals, so sine of theta is opposite over hypotenuse. So sine of theta is opposite, which is my length, over hypotenuse, which is my r. And cosine of theta is going to be adjacent over hypotenuse. So width over r. You're like, that didn't help. Well, it kind of did. Because I could use the substitution property for length and width and plug these in. I just need to get length and width by themselves. So if I multiply both sides by r, then it cancels the r out. And I'm left with r sine of theta equals L. I can do the same thing here. Whoa! So I'm left with r cosine of theta equals W. Y'all, when I first solved this problem independently, this is where I started. I didn't even know if it was going to get me anywhere. And that's okay. Sometimes you have to just start playing around with the numbers, plugging things in, messing around with the problem to see where you can get. Now, if I looked at this problem and didn't have any clue where I would go, what would I do? I would flag the problem and move on. I wouldn't solve this problem first, especially since when I looked at this problem, it took me a couple of minutes to really figure out how to solve it. And I don't want to waste time on my test doing problems I'm not entirely confident I know how to do. So I'm going to flag it and I'm going to move on. And when I get to the end of the test, I'm going to go back to my flagged problems and I'm going to work on them because now I have the time, right? So moving on, that was just my soapbox for the day. I can now plug this value in for L And I can now plug this value in for W. So now I have area equals, because remember, we're finding the area of the rectangle, r sine of theta times r cosine of theta. I can simplify by doing r times r equals r squared, and I'm left with r squared sine of theta cosine of theta. Y'all, you should know what sine theta cosine theta is. If you are taking a 6 through 12 exam, you should know the basic trig identities. If you are taking the 6 through 12, 7 through 12 exam, you should know the very most basic trig identities, and one of them is sine times cosine equals 1/2 sine of 2 theta, right? Now, pro tip, secret, I didn't know that off the top of my head. I'm also not studying for this, but it's not something I keep in my head. So if you didn't know it, don't worry. Go study it. It's not a big deal. But you will very rarely see me say, memorize that. This is one of those things that you have to just memorize. So I'm going to put this in a little bubble because it's just an identity that you should know. Sine of theta times cosine of theta equals 1/2 sine of 2 theta. Substitution property. I'm going to replace this for this. So r squared equals, nope, not equals, r squared times 1/2 sine of 2 theta. And now the properties of multiplying fractions, I can do r squared divided by 2, because 1/2 times r squared, I don't know why I keep putting equals, sine of 2 theta, which is a. R squared divided by 2 sine of 2 theta. Once you solve it, you realize, oh, it really wasn't that hard. Once you start playing with those thetas and like using the answer choices to realize that I'm gonna need to use sine and cosine to solve this problem, it really starts to get to the point where you're like, that really wasn't that hard. Especially if you know basic trig for your right triangle properties. All right, let's go on to the next problem. A circle, let me disappear for a minute. A circle has center 3, -2, and a point on the circle at 1, -6. Which of the following points is also on the circle? Which of the following points is also on the circle? So there's a couple ways we can do this. I can draw it. I can find my center, 3, -2. I can plot 1, -6, 1, -6. Oh, that's not 3, -2. That's -3, -2. 1, 2, 3. And 1, -6, 3, 4, 5, 6. And I can attempt to draw a circle there. And then I can look at my answer choices and see if any of them are like way out of the way. So -2, +2. That's going to be up here somewhere. 5, -6. 1, 2, 3, 4, 5, -6. 6, -1. 1, 2, 3, 4, 5, 6, -1. 2, -2. 1, 2, -2. Okay. Some of these points are too close for comfort, right? I could look at this and be like, oh, I think it's 6, -1. And if I was running out of time, I would probably pick 6, -1. But, or no, not 6, -1. 5, -6. Sorry. Because on my circle that I just drew, that's not really that great of a circle, 5, -6 is right here on the circle. But I also didn't draw a really good circle. But 6, -1 is a little too close for comfort. This one could be on the circle, and it's just a result of me not drawing a circle really great, right? So I don't want to do that because I'm like, I don't know. But if I was running out of time and this is all I had and I had 30 seconds left and I had to choose an answer, I would choose 5, -6. Is it right? Is it wrong? I don't know, but that's what I would choose. 3, -2 and 2, -2, I can automatically get rid of that one. So that's like a self-elimination one. Because if this point is on the circle, then the point that's literally right next to the center of the circle is not going to be an option. So I know I can get rid of that one. And I can almost confidently get rid of -2, 2, because it is further away from that center than 1, -6 is. But if I wasn't sure, or I had all the time in the world, I finished early and I can check it, this is how you would check it. Distance formula. So this distance right here is a radius because it's the distance from the center to an outside point on the circle. And so in order to figure out what other points are on the circle, I need to test the distance formula and see how far away these guys are from the center. And that's going to tell you if it's a point on the circle or not. So the distance formula says square root of x minus x squared plus y minus y squared. That's your distance formula. So I'm going to use this point and this point to get a baseline distance. So d equals the square root of x minus x squared plus y minus y squared. 3 minus 1 is 2. -2 minus -6. So -2 plus 6, because a negative times a negative is a positive. -2 plus 6 is 4 squared. So this equals the square root of 4 plus 16, which is the square root of 20. Don't start freaking out on me now. Don't start going, oh no, I don't like square roots that are by themselves when I don't have a calculator. You don't need a calculator. All I'm about to do is the distance formula with one of these points and seeing if it equals the square root of 20. If it equals the square root of 20, it's a radius. If it doesn't equal the square root of 20, it's not a radius, so it's not on the circle. That's how you're going to test it. So D equals, I am going to test 5, -6 because it's the closest to what I actually think the answer is. Square root. Now I'm going to do this point because that's the center and this point. X minus x squared plus y minus y squared. 3 minus 5 is -2 squared plus 4 squared. 2 squared is 4 plus 16 equals the square root of 20. We found our answer. Now, let me show you what would happen if we tested a point that was not the answer. I'm going to test this point right here. D equals the square root of x minus x squared plus y minus y squared. 3 minus 6 is 3 squared, -3 squared. 2 minus -1 is a positive, so -2 plus 1 is -1 squared. -3 squared is 9, plus 1 is the square root of 10. Because that did not equal the square root of 20, it is not the correct answer. Does that process make sense? Now, I got really lucky that I drew an okay enough circle where that point landed on the circle. That does not happen very often. And so, like I said, I would not rely on that method to choose the correct answer unless I was running out of time. And then that method is pretty much the method that you're going to use because you don't have enough time to do all that distance formula stuff, right? All right. Problem number 3. Woo, we are heavy in the high school, middle school area tonight. But it was a popular request last time, so that's why we're seeing a lot of these kinds of problems, because there was a high request for MTTC 5 through 9, FTCE 5 through 9, and Praxis 5135. So if you are an elementary school teacher and you want to see some elementary stuff, let me know in the comments, because I am doing a next week section. Right now, I have graph problems with parabolas on there and no calculator problems, like not using the calculator problems. So just if there's something specific you want to see, let me know. All right, what is the area of the shaded region if X is the center of the circle? What is the area of the shaded region if X is the center of the circle? So all I'm trying to do is find the area of each one of these little sections and adding them together. No, those are not triangles because they have a curved edge, and triangles do not have a curved edge. But what I do know is I need, like in my planning process here, I need to find the area of the square, and then I need to subtract the area of the circle, and that will give me the area of the shaded regions. Now, you say, how do you know it was a square? How do you know it's not a rectangle? Good question. When we look at this image and we know that this is a circle and the 16 is a diameter, then that means that this is 16. And that also means that this is 16. If both of those are 16, then it's a square. Because if this is 16, then this is also 16. And if this is 16, then this is also 16. Well, the area of the square is 16 times 16. Let's use our calculator for that. Could I do that without using my calculator? I absolutely could. I could do 16 times 16 and I could do that without a calculator. 16 times 16 is 256. Now I have to find the area of my circle. The area of my circle is going to be pi r squared, where r is my radius. Now, don't make the mistake of saying that the radius is 16. That is going to be one of the more common, mistakes that people make, is that when they're in a rush, they're just going to throw 16 into there. However, it's actually going to be 8 because the radius is the distance from the center to the outside of the circle. And that is only half of 16. So I have pi times 64. And I am going to use, because I see that none of my answer choices have the actual like pi symbol and they all are full numbers, I'm going to use 3.14 as my approximation for pi. So 3.14 times 64 is 296 hundredths. That's the area of the circle. So area of square minus area of circle equals none of the answer choices. I thought, I vividly remember fixing this, and I don't know, I must not have hit the save button, but none of those answer choices are an option. The answer is 55 and 4 hundredths. None of those answer choices are a choice. So we're just going to cross those out. But I vividly remember fixing that, so I really don't know what happened there. All right, let's go ahead and read the next problem. Ooh, here's a problem for everybody. In a fish tank at the pet store, there are 15 goldfish, 4 catfish, and 9 zebrafish. A customer comes and purchases 3 fish at random and takes them home. 2 goldfish and 1 zebrafish. 2 goldfish and 1 zebrafish. The next customer that comes wants to purchase 2 fish at random. What is the probability that the first fish is a goldfish and the second fish is a zebrafish? All right, so this is basic probability. You'll notice that this says 4B because 2 weeks ago we did the 4A problem, which was this problem. But they said the question was something to the effect of like, what is the probability that the fish is a goldfish? Like the customer was only purchasing 1 fish. And so they wanted to know what the probability was that the fish was going to be a goldfish or something like that. But when we are doing dual probability, we're looking for the probability that the first fish is a goldfish and the second fish is a zebrafish. So I need to do probability number 1 times probability number 2. And remember, probability is my desire over my total possible. My probability is my desire over my total possible. So my total possible, one would think, would be 15 plus 4 plus 9. However, a customer comes in and purchases fish. So there are no longer 15 goldfish, 4 catfish, 9 zebrafish in the tank. Sorry. My little one just like randomly opened the door to the room that I'm in, and my husband is playing with him, but he must have like gotten distracted, and he opens the door. He goes, oops. It was just the funniest thing. And then he just stood there, and I was like, I can't really do anything. So my husband came running and fixed it, but that was really cute. So 15 goldfish, 4 catfish, 9 zebrafish, but we don't have that amount anymore. So someone came and purchased 3 fish. So they purchased 2 goldfish and a zebrafish. So I don't have 15 goldfish anymore. I now have 13 goldfish. And literally, if this was the problem, I would literally be scratching it out and like writing it like this. And then I have 1 zebrafish. So they took 1 zebrafish. So I no longer have 9, I have 8. So now the next customer comes in and my total possible is 13 plus 4 plus 8. And they want to purchase 2 fish. The first fish is a goldfish. So my desire is 13 goldfish. But then they pick the goldfish out of the tank. So now for my second probability, I don't have 13 plus 4 plus 8 is 25, there's not 25 fish in the tank anymore. There's only 24 fish in the tank now. And the second fish is a zebrafish. Well, the first fish was a goldfish, so the 8 didn't change. So I still have 8. Now I just do basic fraction multiplication. 13 times 8 is 104. 25 times 24 is 600. But I can simplify that. I can divide those both by 2. 600 divided by 2 is 300. 104 divided by 2 is 52. Those can both be divided by 2 as well. $52 divided by 2 is 26. 300 divided by 2 is 150. And those can both be divided by 2 as well. 13 over 75. So my answer is B. All right, y'all. We are out of time. So here's what I want you to do. In the comment box, let me know what you want to see me go over in the upcoming weeks. I have graphing problems with parabolas. I have no calculator problems. What else do you want to see? I'm going to turn it back over to Dr. A, but I will see you next Wednesday. Let me know what you want to see in the comment box and have a wonderful week. Bye.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. It doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.